Learn how to determine the enthalpy change for a reaction using Hess's law and given thermochemical equations. We need to find the enthalpy change when tin reacts with 2 moles of chlorine gas to form tin tetrachloride. Let's start by understanding what we need to find and what information we have. Our target reaction is tin plus 2 moles of chlorine gas producing tin tetrachloride. We need to determine the enthalpy change for this reaction. We are given 2 thermochemical equations with their enthalpy changes. Equation 1. Tin plus chlorine gas forms tin dichloride with an enthalpy change of negative 325 kilojoules. Equation 2. Tin dichloride plus chlorine gas forms tin tetrachloride with an enthalpy change of negative 186 kilojoules. Now let's understand the principle we'll use to solve this problem. Hess's law states that the total enthalpy change for a reaction is independent of the pathway taken. Whether we go directly from A to C or take an indirect route through B, the total enthalpy change is the same. The direct enthalpy change equals the sum of the individual step enthalpy changes. Let's examine how the given equations relate to our target reaction. The first equation shows tin reacting with 1 mole of chlorine to form tin dichloride. The second equation shows tin dichloride reacting with another mole of chlorine to form tin tetrachloride. Notice that tin dichloride appears as a product in equation 1 and as a reactant in equation 2. This means tin dichloride is an intermediate species that will cancel out when we add the equations. Now let's add the 2 equations together to get our target reaction. We start with equation 1. Tin plus chlorine gas gives tin dichloride. Then we add equation 2. Tin dichloride plus chlorine gas gives tin tetrachloride. When we add these equations together, we get tin plus chlorine plus tin dichloride plus chlorine gives tin dichloride plus tin tetrachloride. Now we cancel tin dichloride from both sides, since it appears on both reactant and product sides. After canceling, we get tin plus 2 moles of chlorine gas gives tin tetrachloride. This is exactly our target reaction. The equations add up perfectly. Now let's calculate the total enthalpy change using Hess's law. According to Hess's law, the total enthalpy change equals the sum of the individual enthalpy changes. We add negative 325 kilojoules plus negative 186 kilojoules. That's negative 325 plus negative 186 kilojoules, which equals negative 511 kilojoules per mole. Therefore, the enthalpy change for the reaction is negative 511 kilojoules per mole. Let's understand what this result tells us about the reaction. The enthalpy change is negative 511 kilojoules per mole, which is a negative value. A negative enthalpy change means the reaction is exothermic, releasing energy to the surroundings. The reactants start at a higher energy level, and 511 kilojoules of energy is released as the reaction proceeds to form the lower energy products. Let's summarize the key steps for solving this type of problem. Step 1. Identify the target reaction whose enthalpy change you need to find. Step 2. Check if the given equations can be added together to produce the target reaction. Step 3. Add the equations together and cancel any intermediate species that appear on both sides. Step 4. Add the corresponding enthalpy change values to get the total enthalpy change. For the reaction of tin plus 2 moles of chlorine gas forming tin tetrachloride, the enthalpy change is negative 511 kilojoules per mole.